Good morning or good afternoon, ladies and gentlemen. Thank you for joining us. Welcome to ITRI MMSL, Mechanical and Mechatronics Systems Research Laboratories 2023 Online Business Matchmaking Forum. For the next 100 minutes or so, our team of researchers will lead you into Taiwan's leading-edge technologies concerning smart mobile vehicles and smart manufacturing. After today's event, you will have the opportunity to engage one-on-one with our experts to explore further opportunities of collaboration. So don't forget to sign up for the matchmaking meetings through the QR code that will be shown during the break and at the end of the event. Without further ado, let's first welcome Deputy General Director of MMSL, Bingxiang Yang, for some opening remarks.
Welcome to the 2023 MMSL Online Business Matchmaking Forum. My name is Bingxiang Yang, the Deputy General Director of Mechanical and Mechatronics System Research Laboratories in Industrial Technology Research Institute, or ITRI, in Taiwan. ITRI is a world-leading applied technology institute with more than 6,000 employees. Its mission is to drive industrial developments, create economic value, and enhance social well-being through technology R&D. To innovate a better future, ITRI enhances the developments on 3 application domains: smart living, quality health, and sustainable environments. The Institute strives to use technology innovation to shape new lifestyle, develop market-oriented solutions, and find uncontested spaces. Mechanical and Mechatronics System Research Laboratories, or MMSL, is one of the research units in ITRI. We focus on research and developments in smart vehicles and smart manufacturing. This is our very first online business matchmaking forum. In the following 100 minutes or so, we will introduce you our recent research and developments, covering electric vehicles, mainly on the transmission and chassis design, autonomous driving technologies, multi-axis motion control, high payload drone developments, smart factory integration, low carbon or zero carbon manufacturing technologies, also in semiconductor manufacturing equipment, and robotic-related technologies. We aim to provide you a quick overview of our focus and capabilities. Most importantly, we hope you are able to discover some common interests that we can do business or collaborate with in the future. After the presentations, please take a few minutes to fill out the survey. We will follow up with you if you are interested in our technologies or are searching for solutions that we might be able to provide. We are looking forward to potential partnership with you. Hope you enjoy the 2023 MMSL Online Business Matchmaking Forum.
Thank you, Deputy General Director Yang. The first session of our program today will focus on the technologies of smart mobile vehicles. In the following 40 minutes, our 4 experts will share on electric and autonomous vehicles, motion control solutions, and heavy lift drone technologies. The YouTube chat function will be enabled throughout today's program. Should you have any questions or would like to learn more about a specific topic, please leave your message. We will gather your requests and discuss them with you during the one-on-one matchmaking meetings that will be arranged after the event. Let's now welcome Deputy Manager John Cao to share on EV transmission and chassis.
Ladies and gentlemen, my name is John Cao, and I'm very appreciated to have the opportunity to give you a brief introduction of our development in ITRI, EV transmission and chassis. And it's our organization. And my department belongs to the Vehicle Homologation Division of MMSL. And there are 3 departments. The first one is the Vehicle Certification Department, and they are responsible for the energy and emission research, also the vehicle certification. And the other one is the Department of Chassis and Dynamics. They are responsible for the spatial heavy vehicle chassis layout and the design. And I belong to the Precision Transmission Technology Department. And we are responsible for the EV transmission and the high efficiency precision reducers. Also, in the recent years, we are working on the chassis of commercial EV. And we are one of the oldest departments in ITRI. We have more than 30 years experience in gear transmission, design, and development. And our products are used in the aircraft, tool machine, turbine, also the heavy vehicle transmission, also the elevator reducer. And in the recent years, we are focused on the EV transmission and the precision reducer for the industry, also the EV chassis. And for the vehicle transmission, we focus on the gearbox development and its test and verification, also the components design. And for the industrial reducer, we are working on the RV reducer and the planetary gearbox, also the Industry 4.0 smart gearbox. And for the vehicle chassis, we are working on the commercial EV chassis and the special use chassis. And in EV transmission, we could provide total solution for the design and development for the transmission. And based on the different kind of vehicle specification and performance requirements, and our team could offer a customized design for the gear ratio, also the housing, and in its case mounting. And we are focused on the research and design for the vehicle and transmission system. There is our general R&D workflow for transmission system, and we follow the R&D V model. And in this slide, it's the left-hand side of the V model. We have vehicle simulation and low cycle synthesis technology for vehicle dynamics to verify the system's and products requirements. And we design new transmission concept for the electric vehicle. And about the detailed design and analysis, we have ability to design gears and synchronizers, also clutch and parking system. And in the system level, we have system integration design, system life analysis, and gear contact pattern, and also the NVH analysis. Then for the documentation, tolerance investigation, 2D drawing, and design verification plan are all our own capabilities. Then in the right-hand side of the V model, from the 2D drawing and the DVP, we manufacture parts by ourselves or by our suppliers. Then we assemble the parts and system by ourselves in our factory, also to test the subsystem and system in our own facilities. And here are our general items for system verification plan for the transmission system. From start test, which check the assembly is okay or not. Then replication test for sealing and cooling performance. Mechanical test and efficiency test for system performance and transmission efficiency verification. Also, the NVH test for sound and vibrations. And here are some test bench for our transmission system, like powertrain test bench, transmission test bench, also the clutch and e-parking system test bench. And we have a factory in our campus. Here are some of our facilities for jig, gear, and shaft manufacturing, like our Cap Niles gear grinder and Studer S31 cylindrical grinders. Also, for the gear manufacturing process research, we have a heat treatment factory in our campus to test the heat treatment process for our transmission gears and shafts. And for the NVH test equipment, we have the gear measurement and the 3D dimension examination lab, also some NVH equipments. And for our transmission products, for EV transmission, the first one is a 2-speed automated EV gearbox. It could apply to a 140 kilowatt peak power traction motor. We have completed the test bench test and vehicle test. We apply this gearbox to a first generation Nissan Leaf, and this video is showing the parking test on a 35% slope and the high-speed shifting test on a dyno. And here are our two-speed EV gearbox specification. And there are two types. First one is with the synchronizer, and the other one is with a dual clutch. Another EV transmission product is the single-speed EV gearbox, and we have 4 models for a single-speed system. And it could apply to the peak power 120 kilowatt to 150 kilowatts motor. And these two are for the 120 kilowatt of single gear ratio from 3 to 8. And especially for the last one model, it's a single output shaft and could suitable for a small truck with a rear drive system. And for the e-bus and heavy-duty vehicle, we have an integrated planetary gearbox and combine the gearbox and traction motor. It could apply to a 220 kilowatt peak power motor. And for the industry reducers, for RV cycloid reducer, we have two models now, and rated torque are from the 245 to 784 Newton meter. And for the chassis development, first one is our electric commercial vehicle chassis, and it could apply to a 3.5 tons commercial EV with wheelbase 3,300 millimeter. Also, it's a rear drive system with a single-speed electric powertrain. In this project, we have done the design and prototypes for the powertrain, frame, steering, brake, also control, suspension, and its battery and transmission systems. And the other one chassis project is for a 12 tons and wheelbase 3,300 millimeter heavy-duty vehicle. It's a diesel engine powered system with 4-wheel drive transmission system. And in this case, the development including the frame, brakes, and steering, also the cooling, suspension, powertrain, and the transmission, also the fueling system. And here are some of our domestic industry partners, like the local vehicle and the e-scooter OEMs, and some domestic robot and reducer companies. So here is the end of my presentation. Thank you.
Thank you, Deputy Manager Cao. For our next topic on an introduction of ITRI's autonomous vehicle, let's welcome R&D Manager Victor Liu.
Today we'll give a brief introduction of ITRI's autonomous vehicle technology. Let me give a brief history of the self-driving car technology effort here at ITRI. So we started a little bit more than 4 years ago, back in 2018. Since then, we have become the first team in Taiwan to pass government testing and to obtain the first self-driving car license plate in Taiwan. Since then, we've also successfully collaborated with multiple local governments to do some public self-driving demonstrations, including with Hsinchu City and Taoyuan City and Taichung City. In addition, we also have a lot of private sector collaborations, both domestically and internationally. So this includes, domestically, we worked with Hsinchu Logistics Company, and internationally, we've worked with several renowned car manufacturers and highway operators. So one of the main selling points of our technology is its modular architecture. So it consists of several subsystems that can be easily adopted to various operating scenarios in various vehicle types. So Shown in this slide, you can see actual cars on which we have successfully deployed our self-driving technology. So this includes on the top left, purely electric vehicles, and on the bottom left, we have diesel buses, and in the middle, there's the mid-sized truck for logistics applications, and top right, there's a hybrid vehicle, and on the bottom right is a freight truck with a trailer box attached to it. So all those vehicle types can, our technology can be successfully used on. So our technology stack consists of these subsystems shown on the right. So this includes the action and control module, perception, mapping, localization, tracking, prediction, and so on. So these subsystems will can be interfaced with these various sensor types. So that includes the camera, LiDAR, GPS, radar, and even external communication sources, such as roadside units and some control center living in the cloud. All these real-time signals will get passed into our subsystem, which will then form some understanding of its surrounding with the help of these various signals, and to compute the control signals to the drive-by-wire system so that the car can do a safe and performant driving. One of the most important parts for ensuring safety and performant driving, self-driving, is the availability of a HD map. So a HD map will provide, it's a centimeter accurate map that allows the vehicle to get localized onto it so that the vehicle knows where exactly it is in the world. And it also provides additional rich information about the surrounding that the self-driving car may not be able to directly perceive with its sensors. So we provide tools that allow us to create these HD maps at scale. So on this slide, you can see some examples of HD maps created using our tools. Immediately below the text is the point cloud map and vector map of the ITRI campus, and the bottom left image shows the scale that is achievable by our mapping tools. And in the middle, we have mounted on a car the mapping sensors this low-cost mapping toolkit that we built. And on the right, this video shows the self-driving car being localized onto the HD map. So the perception module is responsible for taking all these real-time sensor streams and combining them, analyzing them, and in real time forming an understanding of its environment. So this includes knowing where the location and the speed of its surrounding cars and pedestrians, even scooters. And also on the right, so let me play this video. So this perception system is able to know about the location and the speed of surrounding objects. And it's also responsible for analyzing the image and finding traffic lights and correctly determining the state of the traffic lights. In addition to these sensors for sensing the vehicle surrounding, we can also augment these senses with information from farther away. So like roadside units with cameras from farther away or even around a building corner can share its camera. It can share its view through wireless communication with the vehicle. So this will further expand the horizon or the amount the field of view that the vehicle has, so it could be more safe and perform more performant driving. So our technology stack includes software to support this kind of connected V2X communication. So in this video, you see the car's real-time information is being passed on to, it's being collected and aggregated. Its status is being monitored from a cloud, from a control center in the cloud. So you see the location of, so the top view is the car inside the car, and the bottom view is what is seen from the control center. So we can see where the car is, and we can monitor various statuses of the car. Safety is the most important part, is probably the most important requirement of self-driving cars. So we place a lot of emphasis on safety. So we adopt a lot of safety standards, including ISO TIF and ISO 26262. And in addition, we also develop a collection of simulation tools that allow us to simulate and test the functionality of our subsystems prior to actual deployment in real world. So these simulation tools include like purely virtual simulations, and it also includes these mixed reality simulations where so part of the signal being inputted into the car is real signal, and it's augmented by these fake virtual signals. So I'll quickly show a video of this. So you can see that the car is actually driving on the road, but that blue box in front of it is a fake car, is a virtual car that is being injected into the system just to test its behavior. So you can see the car, once the car has pulled up to the side, then our car is able to successfully overtake it. And here you'll see a scooter cutting in front of it, and our car is able to successfully slow down. And pedestrians that suddenly run into the street, our car can also respond accordingly. So being based in Taiwan, we're subjected to a lot of very challenging traffic scenarios, such as these very dense motorcycles, a lot of motorcycles surrounding you, and a lot of illegal parking, and occasionally stray dogs running out in front of you. So all of these challenging scenarios has forced us to continue to innovate, and the result of which is we have a much more robust, thanks to these challenges, the result of it, which is a very robust self-driving system that is able to handle these very, very challenging situations. So this is our car driving in a typical Taiwanese street. So there's a lot of illegally parked cars on the side, and our car is able to adjust its trajectory accordingly based on these illegally parked cars. So that concludes our brief introduction of ITRI's self-driving car technology. And we look forward to hearing from you if you have any further questions, or if you would like to learn more about our technology. And as always, we're always looking for new ways of using this technology to solve real-world problems. So we'd love to hear from you if you have such a use case. Thank you.
Thank you, R&D Manager Lu. Now let's welcome Manager Fengqi Li to share on multi-axis motion control solutions.
Hello everyone, thanks for your coming to this meeting. This session I want to introduce about multi-axis motion control solutions. Multi-axis motion control solution. And my name is James Fengqi Li. I'm the manager of the Mechatronics control department. And we have provided our motion control solutions. In this session, I want to introduce for you. Okay. In the first slide, I want to show you what's the key part of our solutions. Here you can see in the traditional mechanical system, if you want to produce, for example, if you want to produce your mobile phone case, your mechanical software engineer, you can to use the CAD file, you finish your CAD file. After that, you can do automatically to generate the CAD file. After the CAD file, maybe as you know, in the traditional is generate the GM code, which your machine can to finish the line trajectory or the CW circle or something else. But in our solution, we have our private library. We can call it the motion control command library. The user can use our library. You can see the example, MCC line, MCC circle, to finish all over the trajectory. What do you need? Okay. And here, this part is our key component. This is our in the mechanical system part. Okay. The most important, we will focus on thermal command generation. We provide a lot of API for our user to use to meet their need. Maybe the isolation, deisolation, interpolation, to avoid the vibration of a machine, for example. After that, we can send out to the plus command or the vertical command. Vertical command you can say also you can set is the velocity command or the torque command. Send out to the server driver. Server driver is a closed control loop. All over this one we can see its controller. And here, maybe someone will call what's controller. Maybe the purple block. It's about the controller server command generation and the server motor and the server driver. But here I will show you to let you know we focus on server command generation. Okay. Next slide, I want to show you over the solution what we provide. You can see the SSS. We can also call it the traditional server control. You can send out the plus command or the vertical command, or you can use the velocity or torque command. In the YSS, we will let you know we will focus on PC base. Okay, in the Taiwan ITRI, we provide our research and development about motion control ASIC with the actual ASIC. And after that, we will also provide motion control card. It also maybe 4 SS or 6 SS. You have a PCI or PCIe interface. Also. And you can also see the YSS. You can maybe always be used in standalone. Standalone is just need to power on it. Because our third generation is intelligent motion control platform. Okay, it is the IMP3. It has built-in the CPU and a real-time operating system, VxWorks. So it also have a PCI interface. You can use it in the PC base, or you can just stand alone. But only standalone solution, we also provide IMP610S. Okay. And in the recent years around the world, maybe in the digital control, or you can also call this digital servo, is more and more popular in the industry. And you also can separate to the private protocol, something like a SSCnet or Mechatronics, probably something else. But here we provide is public. It's from German. It's a back half. It's a CAD motion control platform. We also focus on the master controller. It's called EMPS. Okay. In the machine, in the industry, a lot of extended input and output module we need also. We also provide in the second generation, we are actual with the S-Link solution or IMP3 or AIO. And our ESA-CAD also have a slave solutions. All of this why we let you know we have provided the product. Is a finish, is a very good product for a motion control solution. Okay. Next product will let you know we have a hardware. We also need to do the software. We need our motion control command library. So integrate together. And MCCO is the most important part because we accumulate more than 20 years. The most important is about trajectory planning. And in the CNC, maybe you can call it point to point, or you can fast motion. The most important in very popular is the line trajectory, arc, circle, or helical. Our circle trajectory not only in 2D, it also provides 3D. And we also provide a lot of API. In the machine, you need to set your mechanical parameter, your system, something else. And we also some advanced. You maybe you wish your machine will blend in, you will do velocity will very smooth, or checking overall speed. And you also maybe have a DM module or AD. You have some sensor want to into your system, your controller. All very soon we provide lots of good and API to integrate your controller, maybe in the future in a robot, CNC, something else. Okay, so now you can know we provide the hardware and our software and share. And the one is another project I told is ESA-CAD. It's a digital control. Okay, in our user, the most part is about a robotic control. Okay, we also to accumulate our experiment about any kind of controller, but in around recent 10 years, the robot control is most popular. And most important is the Internet Server Protocol. Okay, it's the ESA-CAD protocol. So we cooperate with a German accountants. It's a third party. So we have our ESA-CAD ECM. After that, in the motion control, the most popular and the most important is the real-time operating system. Our solution have our RTS is very stable version, stable product, and it's also used in industry now. But around the world in the industry 4.0, we can to integrate with some industry Ethernet protocol, something OPC-UA or IO-Link, CC-Link, and something else. We can integrate it is ITRI motion controller. And in the driver, in the slave, you can see the servo driver. But this one is different with the traditional, is just only pulse over the velocity. Here is the ESA-CAD protocol servo driver. Maybe some I/O, ADDM module, machine bridging, something else. In the upper side, you can see the industry Ethernet protocol, maybe UI, ERP. The most important, around the world, our research is about big data or artificial intelligence. But you use the ESA-CAD mesh controller, you can easier to meet what you need. You can capture over producer over the data what you want, maybe the velocity, encoder, something else, information. After that, you can do research and develop the AI algorithm. And in the ESA-CAD motion controller, we have maybe more than thousands set was in the production line application. So it's also can to meet now around the world industry 4.0 need. So this is a new generation of our controller. Final, we let you know any kind of a field, any kind of a machine. If you have a use a motor or a servo motor, you can use our multi-axis motion control solutions. Maybe something like a traditional CNC gantry controller. Over here is a touch panel controller. Any kind of a machine. If you have a motor, we can cooperate or to integrate our solution. And here, around 10 years, the most popular and big amount is the 6S architectural robot, because we tend to instead of human labor, and Scala, Delta, any kind of a robot. maybe previous session, we also have to describe about the robot control. But here, we will focus on motion control kernel. We will here will let you know. And here is some interesting, interesting result we'll show you. We also focus on the robot control. But this project we finished with integrate with the virtual reality. In the right side, you can see here is the virtual robot. In the left up side, you can see a physical robot. You can left down, you can see a human. You just like play a game, you can do automatically to generate the robotic trajectory to finish the robot control. In the traditional, you don't need to coding. Maybe the software engineer is not easy to finish it. The most important, you can avoid very dangerous and very hard environment. Something like a painting, polish, something else. So this project will integrate the virtual reality. If you have anything, we can contact me. And the next example just to show you. This project we integrate with the robot control, also use our EMPS kernel. And we to integrate our machine vision to separate different kind of garbage to the same. This is something like this one. Environment is not very clear. So with the robot, integrate the machine to finish to solve this question. This also you just finished last years. Also to let you know. The most important, we have our cooperated around the world. You can see the left column is this one, German, Beckhoff, and ISACAD. We cooperate with the account is the third party. We also the Switzerland, ITRI, the academic organization. In our virtual reality robot control, we cooperate with the ITRI. And we also have, just as I told, the semiconductor application, SRM, GPM in Taiwan, this is Malaysia. Also, we have lots of cooperators, the academic organization over in the industry. And after this meeting, I wish we can have a next step to close to cooperate with all of you guys. If you have any question, you can contact me. Thank you.
Thank you, Manager Lee. Let's welcome researcher Mike Wen for the last topic on this session, heavy lift drone technology.
Good day, ladies and gentlemen. I'm Mike Wen from ITRI. Today, I feel honored to participate in this forum. I will show you some current development stage of the UAV industry in Taiwan. According to the industry survey performed by Market and Markets Analysis in 2020, the broad market value of UAV will grow to $45.8 billion USD, of which the Asian Pacific region is the highest at the 16.6%, followed by North America. On the average, the compound annual growth rate from 2019 to 2025 is more than 15%. In the future, the largest market will be the urban air mobility region, followed by logistic drone market. In 2040, the market size will reach around $250 billion USD, with a target payload of 5 kilograms and above. In March of 2022, with the support of Ministry of Transportation and Communication, Taiwan has established a UAS team of Taiwan. This team is aimed to update the drone roadmap for Taiwan industry of this region. MMSL of ITRI is a founding member of UAS Taiwan. In June of this year, with the assistance of the ITRI Japan office, the founding President Wu led his staff to Japan and signed an MOU with Juida of Japan. This shows the cooperation of Taiwan and Japan in this industry. In August of 2022, the President Tsai inaugurated the Asian UAV AI Innovation and Application R&D Center in Jiayi, announcing the establishment of the UAV National Team of Taiwan. In Taiwan, the Ministry of Economy supports Taiwan by technologically projects to support the development of UAV in Taiwan. The Ministry of Transportation and Communication also in charge of building the blueprint, that is the JOMAP version 2.0 for Taiwan, aiming to gather the industry and government and the research units together to make this industry prosper. In Taiwan, we have a Jiayi County. The local government set up a UAV aerospace industry park in Minxiong, and also in Taipao City. There is a R&D development center, and in Yizhu, there is a manufacturing center. In the future, this Jiayi County will be the center of UAV development in Taiwan. In Taiwan's UAV industry, Thunder Tiger Technology and Geoset Aerospace and the Taiwan Cotronic Intelligent Robotics cooperation, the three companies is the biggest one of this industry in Taiwan. They work hard and they have many modules to help this industry prosper. MMSL of ITRI focuses on the research and development of heavy payload UAV systems. It's a platform designed to commercial, agriculture, and industrial application. I'm going to show you three of our models. The first one is the large UAV with maximum take-off weight greater than 150 kilograms. It won the multi-rotor championship in Middle East international competition, that is DXC 2020 final prize in 2020. Its fuselage can be folded, and it had a good maneuvering and fast deployment capability. The whole unit is IP55 grade, and the payload can up to 50 kilograms. The second one is a medium-sized UAV with maximum takeoff weights in 100 to 150 kilograms. The payload is used a 30-liter water tank and a 10-kilogram lightweight high-pressure cleaning module. This UAV is used for precisely work in the air. The third model is a small UAV with maximum takeoff weight less than 25 kilograms. It is equipped with a positioning platform for high precision landing, as shown in the bottom right. The smart station is used to receive the package from the UAV system. Humans can use the conveyor below. They don't have to attach the UAV itself. So it's safer for people to receive and sending packages. Finally, I would like to show the Taiwan Power's problem in this field. The Taiwan Power have to clean their insulator in their power stage. The power stage has 5 stories high, and people have to carry a lot of stuffs and climbing up to the Taiwan Power to clean the insulators. Traditionally, we use helicopters to clean the insulator in high mountain region, but it's still very dangerous for people to operate in such a high position. So the UAV can be next solution for insulator cleaning for Taipower. Due to Taiwan's green power policy, large-scale facilities such as transmission towers and power plants have been deployed all over this island. In the next 20 to 30 years, there's a lot of needs in maintaining these infrastructures. So because Taiwan is going to be a super aged society, the automation and UAV systems has more and more requirements in the future. Looking forward to the future, the trend of industrialization and commercialization of drones is confirmed. ITRI continue to develop hybrid power and high payload UAVs to support this industry prosper. And this module can be used to improve the diversity of the industry. We can develop many different kinds of vehicles and to many different applications. Finally, we have a YouTube channel on the website. You can search the Mechanical and Mechatronics System Lab in the YouTube, and you can see all our models on the YouTube. These UAV models and application all can be found on the YouTube channel. Okay, thank you for your attention.
Thank you, Researcher 1. This concludes our first session on smart mobile vehicles. We will now take a 5-minute break. We're sure many of you are looking forward to discuss or learn more in detail about the technologies just introduced. Please take this opportunity to sign up for the matchmaking meetings by scanning the QR code shown on the screen, so we may help arrange one-on-one meetings after the event. Feel free to get up and stretch or get a drink of water, and join us back in 5 minutes for the second session on smart manufacturing. Welcome back. We will now start our second session, which will also take about 40 minutes to cover ITRI MMSL's technologies on smart manufacturing. Our next four researchers will share on the challenges and opportunities of smart manufacturing and specific technologies in this field, such as microwave annealing for semiconductors and AI robotics. Once again, you're welcome to leave your messages in the chat room so we may follow up with you after the event. Let's now welcome Manager Wei-De Chung to share on the challenges, opportunities, and future directions for smart manufacturing.
Ladies and gentlemen, my name is Wei-De and I'm the manager of IoT division. Today I'm going to give a topic, the challenge, opportunity, and future direction of smart manufacturing. As the slide show here, I use the OPC foundation material that we can see a lot of communication issues are in the smart factory, which include 1 to 8, the IT information technology, OT, that means the operation technology, the wireless communication, device to device, device to controller, and also there are a lot of equation in the factory, including the machine tools, the robot, the robot arm, the AGV, the pump, etc. So that means to facilitate the smart manufacturing issue, there are a lot of technology we need to include in our division. We are the console in the smart manufacturing, although it including the operation technology or information technology. We also work with a lot of partners in the ITRI campus, which includes like the ITRI Southern campus region, the ICT, the Information and Communication Research Laboratory. So I think we are focused on the 4 areas, like the AI plus AOI, the IoT, the PMS, means prognosis and diagnosis, maintenance system, and we are specialized in the production line optimization. And I will include those topics in the next slide. Okay, I think to make the factory become a smart manufacturing, there are 4 very important issues. Those are, the first one is the IoT, as the slide show here. First, we need to make every device or equipment to be connected together in that way that all the devices can know each other's. Although there are many technology in this area, like the smart machine box, we help the domestic SME before, means the small, medium-sized enterprise. Use the smart machine box, we can let the machine easily connecting to the network. Others also like we need to do the Internet of Things, not only the people, the machine, and the software as well. That's what I mean for the first step for the IoT communication. Next, we can have the quality of the equipment. That means the doctor of the equipment. As the key technology I mentioned before, like the RUL or PMS. The third one is to be a quality of the product. That means the product need to be a doctor to inspect no matter its performance or the reliability. So we can use a lot of machine vision like the AOI plus AI, 3D vision, those kind of technology to help the partner to check their product defect. And the last step is the production line optimization. There are also many technology in this area. The current status in smart manufacturing Taiwan today is major equipment with multi protocols need to know each others because there are a lot of data conversion in the smart manufacturing. System integration is impossible to achieve without the communication model or standard. That's the current issues that we usually face to the partner and telling them that how to make the smart manufacturing more easier. So we think OPC-UA is the future standard. That means with this standard we can let all the devices connect each other more easily. So within these years, we in our division we have a lot of OPC-UA technology developing so far. So the first one I would like to address the M2M. That means the machine-to-machine communication. That is also very important in the IE 4.0 for the life cycle communication and the low carbon manufacturing. The core technology are promote communication standards and OPC-UA information model, import intelligent power communication and different communication technology through equipment manufacturing and quickly build low carbon intelligent device. From these slides, we also know that we work with a lot of famous domestic partners like TSMC, TSMC, AUO, or Merlin, those kind of famous company here. The next one is the diagnosis and prognosis monitoring system. The core technologies are building a prognosis model for rotary machinery based on the signals we fetch from the equipment, like the vibration, the current, the voltage, or some the acoustic, those information. We can say that is a multi-fusion signals we get from the equipment. We also realize the automations online, the prediction and the monitoring, those kind of functionality to make ourselves as the doctor for the equipments. The third one is the doctor of the product. We use a lot of machine vision technology like AOI, and for nowadays we also plus another key technology like the AI in our original machine vision department. The core technologies are divide AI plus AOI technology to leverage the traditional AOI inspection. The next one is developing online AOI and 3D vision quality inspection technology, enable online 3D appearance inspection of workpiece of wide angle, complex pose and high curvature variation service. The last one is the intelligent machine, the optimal control and adjustment technology. The core items are production line, planning and design, energy enhancement, build the technology of position, non-conflict measurement and tolerance analysis, construct a complete AI-driven process control feedback. The last one is assist the industrial to upgrade from conventional production automation to intelligent manufacturing. I think with those technology, our main focus is to make the material efficiency and the energy efficiency. In that way, we can have the low carbon manufacturing and let the factory to become smarter. Thank you very much.
Thank you, Manager Chung. For our next topic on microwave annealing for semiconductor, let's welcome Manager Kunping Huang.
Hello, everyone. My name is Kunping Huang. It's my honor to introduce my study. The topic is microwave annealing for semiconductor. So my outline, I will talk about the characteristic and the breakthrough. And the next is the industrial value. And the final, I will talk about the future development and the application potential. Okay, so for dopant activation topic in traditional MOS structure, so the gate length is from 90 nanometer and progress into the 1 nanometer. So the diffusion length for currently now the generation is almost in 3 nanometer generation. The diffusion length is almost 0. So in the future, so the dopant activation will getting hard and harder because the annealing temperature currently is above 900 degrees C. So it's very easy to make the dopant diffusion. Okay, so in the future, this is the reason why we develop a microwave annealing process, because the microwave annealing the annealing temperature is almost a half of a traditional annealing process. So this slide, I will talk about the characteristic and the characteristic and the breakthrough. So the first technology, I will talk about the spatial model diversification technique. So we use the longitudinal and the transverse mode to increase the model number. So and we also use the even and odd mode to increase the model number. So in such kind technology, we increase 4 times the model number. We know the more model number, we'll get the higher uniformity. Okay, so my next technology, I will talk about the time phase coupling technology. Okay, so for how do we increase the model number in the power supply? So in microwave transmitter, we use the half wave rectified power supply of a transmitter. So if we enlarge the capacitor, so it will make the overlapped coupling microwave. So such kind of technology it can increase 2 times the model number. So if we combine the spatial diversified technology and the time phase coupling technology, so we can increase 8 times the microwave model number. So it can increase the uniformity of annealing very well. So in currently now the MOS structure is progressed into the gate all around structure. So if we continue use the RTA annealing technology, it will make the dopant diffusion. So in the figure, we can see if even the RTA annealing temperature is below to 700 degrees C. So in this case, we only use the 600 degrees. It will make the dopant diffusion into the depletion area, which will make the device failed. But if we use the microwave annealing, the annealing temperature is only 390 degrees C. So we can see it will not make the dopant diffusion into the depletion area. So it can guarantee the device is good. Okay. So this slide I will talk. It will show the coupling microwave mode advantage. If we do not the coupling microwave mode, the uniformity of microwave annealing is only 4.1%. But if we use the coupling microwave mode, the uniformity will down to 0.5%. So in semiconductor, the uniformity we only can accept 1%. So in our microwave annealing technology, the uniformity is only 0.5%. So our microwave annealing process can get good uniformity, so which can meet the semiconductor industry criteria. Okay. So in this slide, I will talk about the consumable cost. Compared to other companies, our microwave annealing system can save around 85.6% for the consumable cost. So it really can save the cost to maintain the microwave annealing system. So in the final, I will talk about the future development and the application potential. So the first is for the chemical synthesis. So because some chemical can absorb the microwave energy, so it can save the energy and the process time to synthesize a new chemical. Okay, so and then the second, for the powder metallurgy, because in the future the metal part will getting small and small, so it also can use microwave to do the metallurgy. Okay, and the third for the carbon fiber, because the carbon can absorb the microwave energy very well. So we also can use the microwave to do carbon fiber synthesis. And then for the solar cell, it's also because the silicon and the CIGS, their chemical bonding can also absorb the microwave energy, so it can decrease the annealing temperature for their crystallization. Okay, and for LED, especially for micro LED, it's near the lower annealing temperature. So the microwave annealing process is very suitable to do the LED annealing in the future. So, and of course, the silicon semiconductor, because silicon have energy very well, so it can use it can use a microwave annealing to do the device annealing, and which can make sure it can get a higher efficiency in semiconductor industry. That's all. Thank you.
Thank you, Manager Huang. Now let's welcome R&D Manager Ruimei Xu to share on advanced manufacturing equipment.
Good day. My name is Ruimei Xu, and it's my honor to represent our team to introduce the equipment technology in advanced manufacturing. Our work mainly focuses on developing equipment for semiconductor or electronics. We start from simulation to optimize the design for a configuration or a process. And then we will construct the key module or even the entire equipment system. We can also establish a pilot line for production validation using the equipment we develop. Sometimes, intelligent diagnostic or analysis module will be incorporated to enhance our technology distinction. ITRI simulators are mainly used for optimizing a process for thin film deposition. For example, like plasma-enhanced chemical vapor deposition, evaporator deposition, or epitaxy process. The simulators are normally coupling with gas flow, thermal flow, physical or chemical model, so that our analysis accuracy can be up to 95%. With the simulator, the process development time can be reduced from 1 week to 2 hours. This simulator technology is also an R&D 100 winning technology in 2017. Plasma has been widely used in thin film deposition for industry like flat panel display or semiconductor industry. ITRI has developed high density plasma source for different frequency plasma system. For example, like radio frequency, very high frequency, or microwave frequency. This high density plasma allows us to increase production capacity with low process temperature. It can also minimize our film damage resulting from ion bombardment during the plasma deposition. In addition, we may also incorporate some diagnostic or feedback control system to have stable process control. Silicon carbide is a key material for next generation power component. However, silicon carbide has very high hardness and high chemical resistance. So that makes silicon carbide is a very difficult material to machining or polish. ITRI has developed a process that combines ultrasonic grinding and also a plasma-assisted polishing technology. We can improve the production efficiency for silicon carbide wafer production. This innovative process also reduces the process cost to approximately 30 to 50%. Nowadays, the electronic package trend goes toward high density and high frequency transmission. Therefore, high VR density with high aspect ratio becomes very important. Here, we develop a copper electroplating technology for high aspect ratio VR. And this VR feeding technology is void-free in aspect ratio larger than 20. Also, this technology is a all-wet process. Not only our plating process is a wet process, but also the seeding layer deposition is done in a wet process. The seeding layer is traditionally done by sputtering. But here we can use our specialized formula to make it a wet process. Therefore, the cost and process time can be significantly reduced compared to traditional VR hole feeding process. Our demonstration for the high aspect ratio electroplating is done on a glass substrate as shown on the figure. The next technology I would like to introduce is a technology called laser-induced metallization technology. Laser-induced metallization technology is a unique process that we can form metal pattern directly on a three-dimensional structural surface. The procedure starts from spraying on a laser-inducible coating to any substrate, either flat or three-dimensional surface. Then it will follow by a laser scan to activate the material. When the material was activated, we put the material into the electroless plating process. And the metal light can be formed directly on the laser-induced area. This laser-induced metallization process is suitable for a circuit pattern or antenna pattern on 3D substrate. So it will allow us to utilize the irregular surface on a 3D object, which traditionally are not possible to use. The final technology I would like to introduce is the aerosol jet. An aerosol jet was developed to form precise fine line pattern through jet printing process. The pattern size can be as small as 20 micron. This is a mask-free technology, so it can be used for versatile material and patterns during designing stage. Therefore, a fast, arbitrary, and large area patterning can be achieved through this aerosol jet technology. This technology can be also applied in circuit repair process. And this would be the introduction for our team's technology. Thank you.
Thank you, R&D Manager Xu. Finally, let's welcome Division Director Su Huang to share on AI robotics in ITRI.
Hello, everyone. I'm going to talk about AI robotics in ITRI. My name is Su Huang. I'm the Division Director of Intelligent Robotics ITRI. So ITRI Robotics established in 2005. In the beginning, we focused on the service robots. We have security robots, tour guide robots, companion robot, and cleaning robot. And as from the year of 2010, we switched our focus to industrial robot, including industrial manipulators and HGVs. So our research focus still on the controller, robotics controller. And in more recent years, software plays more and more important parts in robotics. So we have our own simulators and AMRs. We provide this solution to the industrial for robotic sales and the total solution. So let's have a look at our email robot controller. These controllers have mobile motion libraries, including time, true motion planning, and singularity obstacle avoidance. We have better human-robot interface collaborations and with sensor-free compliance tracking. We use all digitized interface for our controllers. With the help of EtherCAT, the sampling rate can be up to 1 kHz. Option modules, including accuracy improvement modules and hand-eye coordination modules. The CPS robotics is the trend for current use. CPS stands for Cyber Physical System. Our email controllers handles the physical part of the robot control, together with the equipment and sensors. And our simulator, EasySim, handles the cyber parts. We have a CAD offline editor and robot planning for trajectory simulation. We combine these cyber and physical parts to different kinds of applications, including grinding, polishing, weaving, and spreading, painting. So one example of our CPS robotics is Vision Guided Robot, VGR. Our simulator simulates the 3D of the objects and can recognize the objects from the environment. We call this example as a random bin picking. So our simulator has the capabilities of multi-view angles to reduce the blind spot, and then our AI algorithm can determine a best grasping point for robots. So this software can then be implemented to the real world. So our robot can, with the camera, to pick up the workpiece from a piled object, as shown in the videos below. Another example of CPS robots is a robotics grinding and polishing system. And here, in the initialization stage, we import the model, CAD model of the object, also with the CAD model of robots and devices. And then our simulator can optimize to simulate the physical model with the AI optimization algorithms. So here, we optimize the position of the robot and also the trajectory of the working movements. And in the end, we transport this software to a robotic grinding system. In the meantime, we collect real-time data. So we have another quality assessment feedback loop. And here, we have an iteration process to improve the quality of the grinding robot. So our robot can manipulate and also perform better and better. And here we introduce our AMR, Autonomous Mobile Robot. This robot consists of a mobile platform together with a manipulator on top. And our navigation software to deal with the navigation, mapping, localization, allowing the robot to move around in the working places. We have multi-spot navigation algorithms and sensor station navigation algorithms. This AMR can be applied both in industrial applications as well as the service applications. For industrial use, this AMR can transport workpieces in factories and also can be used as an auto forklift. For inspection and surveillance, we have a high power field detection robot. Another part is the service part. Maybe in convenience stores, you can see an AMR moving around, pick and place the goods in the convenience store. And this robot can also be used in hospital for disinfection, and also in airports or train stations for cleaning. We also extend our simulator to a bigger metaverse. This is what we call robotics metaverse. We leverage the powerful computing power from NVIDIA. So our robot twin have the function of AI and also the omniverse realistic simulation and also SQL database. We use this as a basis to apply robot twin to various applications. So in the right side, we can see a realistic simulation for manufacturing process. So this is a simulator of a real factory in Taiwan. We also extend our robotics application to medical use. So the first example is a robotic spine surgery system. So we have software-enabled robotics arm with intelligent medical image guiding. So this high accurate robotic system can assist an operator to perform the surgery. So we now in the process to accelerate the time to market process. Another interesting innovative medical robot consists of a tiny design and a flexible structure. So this robot can be moved inside human body to perform medical or for treatment or biopsy. So our ITRI Robotics handles the robotics issues in 4 aspects. For the thinking part, we have our robot controller and simulator to generate robot programming and the trajectory. For the vision part, we have a vision-guided system to perform the visual-guided or random beam picking application in factories. And this CPS robotics is used to various kinds of tasks in the factory to reduce the human labor or to improve the quality of the manufacturing. And the last part, our AMR systems can be used in both industrial and service applications, providing better, movable, dynamics manufacturing system. So that concludes my presentation today. And together we build a better future. Thank you, everyone.
Thank you, Division Director Huang. This concludes our second session as well as today's event. Our experts shared insightful information on the future trends of smart manufacturing and the technologies that are now advancing in this field. Let's invite Deputy General Director Binxiang Yang back for some closing remarks.
Thank you for attending today's MMSL online forum. I believe you have got some ideas on our smart vehicles and smart manufacturing technologies. For example, we are able to design and develop transmission and chassis for electric vehicles. Our autonomous driving technologies have been tested and verified in many different fields, even in different countries. Along with the ground autonomous driving and transfer the future logistics. In different industries, we incorporate different sensing and actuating technologies to make the process more efficient with better quality. If you would like to know more details about the topics that we introduced today, please feel free to contact us or our representatives in your area. Look forward to interacting with you in the future. Thank you.
Ladies and gentlemen, thank you very much for being with us in these 100 minutes. We're sure you have several takeaways and are even more informed on the latest trends in smart mobile vehicles and smart manufacturing. Please don't forget to sign up for the matchmaking meetings by scanning the QR code to have the opportunity to engage further with us. Thanks again and see you next time.